Hello and welcome everyone. My name is Jarvis, and for the final project for CE170A on Smart City Pitch Idea presentation, I'm proposing a infrastructure to cloud to vehicle congestion pricing technology to mitigate the effect of urban traffic congestion. So a little bit more about myself. I'm a junior study in civil engineering with minors in EECS and data science. I'm interested in ITS, micromobility, EVs, and connected vehicle fleet. My hobbies, I love photography, I love soccer, and I really love cars. So as we know, the urban environment is densely packed with opportunities, but also cars as well. And the traffic really treats us equally no matter we're wealthy or poor, driving a car is fast or slow, or you're in an emergency or not. So that's a problem, especially when it overwhelms the commuters on a daily basis, and its impact is really broad and complicated, both economically and socially. So for example, up to $11 billion were lost in New York City for traffic congestion and $8.2 billion for Los Angeles, according to the 2019 report from INRIX. And in addition, the American Transportation Research Institute estimated that the total cost of congestion in the freight sector was as high as $74 billion annually, with a shocking $66 billion occurring in urban areas alone. So with that being said, I want to propose this technology package integrated into existing road network and transportation planning to be able to incorporate some infrastructure, vehicle traffic communication, and dynamic congestion pricing charge in future targeted cities. So the operation model looks something like this, positive feedback loop in the illustration. And the sensor embedded into the roadway infrastructure will be sensing traffic congestion and performance at selected hotspots. These data can be either pre-processed locally on a process unit or be directly uploaded to AWS cloud for real-time analysis and update the congestion charge in real time. And the pricing and congestion analysis could be then queried and received by commuters via a package receiver or payment unit like Fast Track, either integrated into the central computers via heads-up display unit or be purchased separately by themselves. Once the operation expands, the road receiver could also safely collect more commuter data once the user entered a congestion zone and create this positive feedback loop to better tailor the pricing based on historic data trends and enable more vehicle-to-vehicle communication for crash and emergency detection. So to achieve this model, I want to propose the following technology, and though it's not comprehensive, as the sensors should be adopted according to city conditions like size, roadway condition, and weather. So first, we have the sensing technologies. We want to get the best out of the existing ITS sensor networks, and these can include the traditional inductive loops and magnetometers by working with city and local transportation agencies. For cities with congestion hotspots, additional over-the-roadway sensors can be added. For example, VIP or video image processors, which has an integrated camera and processor converting the image or video feed into traffic flow data in one unit. These can classify multiple vehicles at a time by their lengths and report vehicle presence, volume, lane occupancy, and speed. In addition, microwave radar sensors can also be implemented, and it transmits some frequency modulated waveform, which can detect stop and moving vehicles in several lengths when mounted alongside the road. Moving on to the software aspect, the dynamic congestion pricing will be determined by optimization simulations with previous collected traffic data trained and real-time data. So it will optimize potential congestion zones based on coordinate or per mile metric, depending on the size and preference, again, of local and city governments. Quoting the Bistro Congestion Policy Optimization Project, which is a research opportunity that I participated, which we primarily work with historic data trends in simulations with user-defined inputs and in the coordinate and per mile experiments. And this diagram shows how the positive feedback loop works of the pricing optimization that runs and built on top of micro simulation package of Bing and then packaged into Bistro with user-defined inputs. And in addition, a dashboard for monitoring all these process it would be implementing a software for monitoring, interfacing, and analyze performance and results. To extend the business to more commuters, I want to propose this, develop this standalone receiving unit similar to that of FastTrack, but integrated into a heads-up display that you can mount the dash, plug into the OBD port to integrate with the navigation or trip planning of the commute. And I hope the business could work with auto manufacturer to integrate this receiver as a cheaper option. It will also enable real-time push notification for traffic congestion along the planned trip and updating with accidents or changes in congestion price in real time. So there are two main types of clients for this package. One is the provider, so usually the local transportation agencies like SFCTA or OCTA, and also private toll road companies here. And the second type is the user, so urban commuters and also truck drivers in the freight industry. The value proposition for this technology solution lies in these few areas. It will help to reduce the cost of urban congestion both socially and economically for both the city and individual commuters. And in real life examples like London, as well as case studies on simulation, has also found that even the slight congestion charge can incentivize less vehicle volume in cordon zones. And with case studies before implementation, it will also help to advance equity among the commuter population while generating some revenue for the providers in the long term. In addition, the slight congestion charge can also incentivize more use of public and shared mobility in urban settings to reduce the vehicle emission as a result of less standing traffic. As the side effect of upgrading, it can also future-proof for more vehicle-to-vehicle smart cities application. So lastly, here's an overview of the proposed business plan on a higher level. We want to start off with the software development for different sensors and build up the simulation system in parallel with raising funds and analyzing market for opportunities. Then we'll proceed with case studies and partnering with other firms for consulting and providing services in related fields to start generating some revenue. In phase 3, we begin with piloting projects on the integrated congestion pricing and testing sensors compatibility with the simulation, and also start on development of the receiving unit. It will also then hopefully be followed by a larger scale implementation of infrastructure to cloud. So the left half of the operation model focusing on dynamic congestion pricing in fixed zones similar to express lanes. And once the implementation is accepted and it's mature enough, we can start rolling out the receiver unit to expand the market for real-time applications. So these are the resources that I use for this presentation. And thanks for listening. Let me know if you have any questions. Thank you.